Hello.
Good morning, Nicholas. How are you?
Hi. So please introduce yourself.
Hi, I'm Morgan Littlewood. I'm the SVP of Products at iXsystems, and iXsystems is the developer and provider of what was FreeNAS and is now TrueNAS.
And this is a world-leading open source platform for NAS, right?
That's correct. Yep, we've been doing this for almost 14 years and have developed a huge community of about 250,000 people, and we're the number one open source NAS product out there.
So you say 250,000?
That's right.
So there is also a lot of what's called very advanced networking and storage people using your software to make like products that they might be selling, right?
Yeah, that's right. I mean, our software is all open source. We use open source within the product. We integrate great projects like Samba and OpenZFS, but then we provide all our software as open source as well, and a lot of people integrate it into their solutions for their particular businesses or customers.
And I see on your slide it says 2021. So that in the last 18 months you've been busy improving stuff a lot.
Yeah, we've done a sort of significant change to our products for 2021 that we didn't have in 2020. In 2020, we still had FreeNAS as the primary open source product, and then we had TrueNAS as our commercial product. What we did in end of 2020 was rationalize that, and so we now have just TrueNAS. TrueNAS Core is the open source product, which replaces FreeNAS, and then we have TrueNAS Enterprise as a commercial product, which we use with customers. The big change, though, is that the software between TrueNAS Core and TrueNAS Enterprise is the same. We just have a different license key and appliance to provide the commercial offering.
How can you describe the commercial offering that you have on top, the enterprise part? And so it's based on the whole same core, and all the updates are going from the free stuff to the enterprise stuff. And
That's
it
right.
also goes into all the hardware that you sell, because you sell a bunch of hardware. Do you have like partners and people in the ecosystem also selling hardware that's compatible, or you are the only one selling the hardware for that enterprise part?
People can do what they want, and there are suppliers out there who will take our open source and build their own hardware appliances and provide that. For our particular commercial offering, what we do is we focus on the value add needed for real enterprises, and so that includes high availability. So we can have a dual controller system, so it's no longer a generic server, but a dual controller storage system. And then we provide things like enclosure management and some high-end security capabilities like QNAP to manage keys for large-scale enterprise organizations.
And I see some pretty awesome companies. I think there are a lot out of Taiwan, right? There's QNAP and what's the other one? I forgot.
Synology is
Synology is amazing, right? Do any of these base their stuff on your open source platform, kind of, or they are doing something separate, maybe?
No, they do their own thing. So they build their own hardware and their own software, not open source. So you can't download their software and run it on a generic x86 system like we can. So they have a smaller community, but they obviously focus on selling low-end appliances and have their business that way. Our software is a little bit more higher end in terms of capability because it's all OpenZFS based. It's very, very reliable. So our focus is on people who really need to protect their data over long periods of time, and that applies obviously both to smaller users and photographers, etc., but also applies to larger enterprises.
Do you support, because I like to talk a lot about the ARM CPUs, and there's a lot of activities in the last 2, 3, 4, 5 years with more and more open source support in the whole ARM ecosystem. So how is it going over there for you?
We haven't been focused on ARM. So at this stage, we're still focused on making sure Intel and AMD work very well. But with the new operating systems that we're working on, so it's FreeBSD 13 is next, and then apologies for that. And then for Linux, we're using Debian. They have pretty good support for ARM, and so we'll be able to start working with that type of technology in the future.
So it's possible that there will be the next release or something like that would be multi-platform in that kind of way.
Yeah, exactly. The one thing, for example, though, that is needed for a NAS system to be reliable is ECC memory. So you have effectively extra bits to make sure you can correct any errors. And those sort of things are commonplace in good Intel and AMD platforms. They're not commonplace in ARM systems.
Yeah, it's like it's been brewing for a couple of decades, right? The whole ARM stuff. It's been a lot of smartphones and IoT and stuff, but that's like that's potentially it might bring some other kind of power savings and maybe optimized hardware acceleration of some kind of thing that could be interesting in a different kind of thing. So what are you talking about today in your slideshow?
Sure. So wanted to share with you a bit of a high-level view of TrueNAS and make sure that you and your audience understand that. And then wanted to talk about some new things we're doing with the TrueNAS M series. So so high level, what is TrueNAS Open Storage? It's the ability to support file, which means NFS and SMB, block, which means things like iSCSI, and also Fiber Channel for the enterprise version, and Object, which is S3 APIs, as well as apps. We put it all on an OpenZFS platform, and then we have 3 editions: a free and open source version, which is Core, an HA and scale up version, which is Enterprise, and then an open hyper-converged infrastructure version, which is scale out. And I'll talk a bit about more about those in a little while. And then we run that on platforms. We can run it on clouds or VMs. You can run it on bare metal servers. You can run it on what we call minis, R series, M series, and X series, which are our commercial products. So what we're trying to do is build a very flexible and future-proof ecosystem for software-defined storage. Make sure it's both capable of hybrid and all-flash. It can scale up or scale out. And the goal is to deploy it anywhere: data center, edge systems, cloud, etc. And we try and do that with open source economics. We want to encourage the community to use the software only versions wherever it's appropriate, and so they can test and deploy systems. And then we use the platforms we provide where people really need a reliable system and they need support, and we want to help them get the sort of the similar reliability they get from their enterprise suppliers.
With the ZFS, it's already been a little while that it's been like optimized in, and you were a big part of putting this into the open source. And can you explain a bit what's the advantage of having that kind of a solution? Yeah,
so Open ZFS or ZFS, depending on which side of the oceans you come from, is a fantastic file system that was originally developed by Sun Microsystems, and then Sun was acquired by Oracle. They open sourced that in the mid 2000s. We adopted it and helped integrate it into FreeNAS, which is now TrueNAS, and we've been continuing to develop that with the OpenZFS organization. And so there's about 30 plus vendors there that collaborate to make OpenZFS a great file system. What OpenZFS does is it acts both as effectively a RAID layer, so it's managing disks and disk failures, and it acts as a file system layer, and it's a very, very flexible file system and very reliable. So, for example, there's a scrubbing capability to make sure that data is always updated, and if there's any bit flips or bit rot, those corrections are made automatically without the user having to know about it and without losing any valuable data.
So most people that set up a TrueNAS Core system, for example, they would the first thing they will do, they will format all their hard drives to be using your OpenZFS.
That's right. That's what we call creating a pool. And when you create a pool, you don't really need to know much about OpenZFS, but we just create a pool for you, and that pool uses OpenZFS and sets up all the protection and sets up all the reliability capabilities that you need.
And so here's a slide showing.
This is the full product line. So just trying to show you that these things get used in different sizes and capabilities at all times. So you can start off with bare metal or VMs, or even not running on an AWS instance. You can TrueNAS Minis are sort of small office type systems. We then have R series, which are server format type systems, but they're built for a rack, and they provide very good performance. And then we go up to our enterprise systems, which are the X series and M series, and these have dual controllers to make sure that you have reliability. So no matter what fails, the system keeps on ticking. And then we scale out and enable an M series to go into racks, and then multiple racks if you really want to scale out your storage to huge numbers of petabytes. That's the very high end of the customer base.
So I guess a big part of your business is not just creating the whole ecosystem and the software and optimizing everything, but it's also shipping hardware. Maybe in doing the hardware, you're able to optimize things that the customers need. You can't. Sometimes it's nice to hardware accelerate in certain ways.
Yeah, that's right. So we use things like NVDIMMs, which are non-volatile memory systems modules. We use NVMe drives. We configure them in certain ways. We make sure that the dual controllers can work together. So we optimize a lot of hardware to make sure performance is very good. And then we provide effectively a turnkey system for enterprises to use.
Can you explain it a bit more? Like what you are able to optimize that somebody might not just be able to buy off Amazon, like like do it yourself kind of thing?
Yeah, so you can do most things yourself if you're looking at a single controller system. And so a standard server, you can use NVMe drives, you can use NVDIMMs, etc. But if you want to build a very reliable system, it gets more complicated. Everything has to be dual ported. The software has to be coordinated to make sure that it all works, and that there's no potential failure modes. So we spend a lot of effort on that high availability part of the system and making sure that's all solid.
I'm just guessing here, but so when the software updates come out, and for the open source part, it's kind of like one part, and then you have the other part that kind of runs your hardware. That's how do you call that? And it's not running on a little ARM CPU somewhere in a little NAS device?
No, it's all the same software. And so when you get the open source software, you actually get all of the software we use in the enterprise as well. But we just have a license key for enabling the particular high availability features that we use. And they're really only engineered for use in our systems.
All right, and so there's more and more stuff happening in the scale, but that's like for customers that are doing giant things. Are we talking about cloud companies, or is it just enterprises, or
just enterprises? There are two reasons to want scale out. One is that you want more capacity. And so effectively without scale, we can get to 20 petabytes. So if you want to go beyond that, you need scale out. And the other one is performance, that if you want lots of bandwidth, then it tends to be the case that scale out gives you more bandwidth more economically. And so if you want more than 5 to 10 gigabytes per second, then you really should scale out your systems to deliver that type of bandwidth.
And what's next on your slideshow?
Sure. So just explaining the software modules. So the core TrueNAS includes the file block objects software, all the administration API, platform management, all the security, VPNs, etc., and networking and data management. And then that's all provided in the free version. The scale up HA appliances, dual controller platforms, that's what we were just talking about. And then the scale out version, it provides scale out clusters. And so it's used for software defined storage and appliances. It's hyper-converged, so it includes things like Kubernetes and VMs, as well as scale out storage. So that's the model that we have. Core has been around in a long time as part of FreeNAS. Scale up, we've also been shipping for 8 or 9 years now with HA appliances. The scale out is all new this year, so we're in our second beta of that, and are looking forward to getting that to release in Q4.
I guess maybe also a lot of your partners, you say 250,000 users, but it could be all kind of from like just small users to people who are working for a big company or something. They're setting up the whole file system for them and stuff. But maybe it's also good for the marketing to maybe not use the word free sometimes. Is that why you went to TrueNAS Core instead?
Yeah, so we wanted to have a unified name, and so we felt that at this stage it was more important to focus on the quality in terms of letting people know what our goals were. Free is an attribute of the core system, and we make it very clear that it is free. But we didn't think that the reason why you should use it is because it's free. The reason you should use it is because it's very good.
And what's kind of like the cost to get up to the enterprise or the scale part? Does it have to do with buying hardware that you sell, or does it just they buy a license and there's all kinds of different prices for it, or?
Yeah, we generally provide that enterprise version as an appliance. So we provide it as hardware in a turnkey system. You both need the software additional features we've got, but what we figure is that if you really want high availability, you really need support. And so we wrap support and hardware together and build as an appliance, much like you'd buy an appliance from EMC or NetApp or HP. But our economics are much better, and we try and pass those economics to the customer so that there's a much more affordable system.
So I don't want to interrupt the flow of your slideshow, but I'm wondering, there's a lot of considerations that has to be done in terms of the security of the whole thing, so people don't steal the data, and so it stays, it doesn't disappear. Like, this is like the biggest nightmare in the kind of like humanity, is losing data. It's horrible.
Sure.
It's a horrible feeling. So that's a very important role that you have to enable all the different like redundancies, and that they have to be stable. And also, there's a lot of talk right now about they say it's Russians, but I don't know who it is. Like, people doing the ransomware and going around, like locking up the whole thing. Hopefully, they're not able to get into your TrueNAS and lock it up.
That's right. That's right. Yeah, no, we haven't been hit by ransomware, and we've done a lot of things to make sure that we don't. So in particular with ZFS, there's a capability of snapshots, and snapshots are very easy to take. So you can effectively keep copies of your data, so that even if someone did access one of the other computers on your network and they started writing bad data into your NAS system, you still have copies of the good data from beforehand, and you always keep that. You always try and make sure that your access to the NAS system is very secure, so that people can't connect in or log in and delete things and delete snapshots and delete other stuff. So we provide a lot of tools to make sure that's also very secure. And then finally, what we make sure is that when we run applications, we make sure they never have root access to the storage system. And that is the key to keeping things secure. And we know that things like QNAP and Synology have had problems that way, where their applications, which they add onto their NAS systems, provide root access. And that's the back door that the ransomware people need.
Because I'm every time I see Synology at the Computex, it's so impressive with all the apps and stuff that are around there. But you don't want to have like the HVAC system or whatever it is. The stories are that where people access that and suddenly they have access to all the data.
That's
right.
That's
not possible. Because everything is firewalled, and
the way that we build TrueNAS, yes, it is firewalled. That any application never has root access, and but yes, there are other technologies and other systems that do have that problem, and we try and avoid it very hard.
All right, and your next.
Sure. Yep. So just wanted to give people an idea of how large these systems can get, and what we're doing with the M series to make it more attractive. So we introduced a TrueNAS M60 at the end of last year. We started shipping it this year, and it's now become our flagship product and is generating a lot of revenue for us. It's a 20 gigabyte per second and 1 million IOPS machine, so it's really capable of dealing with thousands of VMs and NFS SMB clients. It has 64 cores and 1.5 terabyte of RAM in it to give it performance, and then NVDIMMs, which is that special technology for accelerating writes. It's a non-volatile memory modules. So with these systems, what we do is we take one of those head units and we connect it up to 12 of the expansion shelves that are down below. The expansion shelves are getting larger. Our largest one right now is 102 drives, 18 terabytes each. So you can effectively get almost 2 petabyte of data in one shelf, and then you can add 12 of these shelves to a system. And so you can build a very big system. And then our focus is on making sure that everything is very reliable, and we achieve 5 nines reliability on these systems so that people can deploy them and know that they'll be the data is both preserved, but they can always access that data. And,
that's like that's massive performance, no? And but this is in demand. There's the industry wants more and more. Like every year, there's more and more people use. What is the storage is growing like exponentially or not? I don't know. It's like just growing so much.
Yeah, it is effectively growing exponentially. Most of the growth numbers for data storage are from a terabytes or a petabytes point of view. They're growing at 40 to 50% a year, right? So there's a huge growth in the amount of data. What's challenging for most organizations is their budgets for storing data are not growing at 40 or 50% a year. They're growing at 5 to 10% a year. And so what we're trying to do is help our customers handle that problem, that their data is growing faster than their budgets. And so they really need an economic solution. And that's why open source is such a key technology for making sure that you can deliver that storage more economically.
Because this looks like, are you claiming this to be the fastest NAS storage system?
It's the fastest ZFS storage system. ZFS being the open source technology, there's nothing faster with that. Can you build faster storage systems? Yes, there are people that have done very hardware-orientated NAS systems, so special chips, special systems, etc., and they get great performance. So no question there. But you then have to pay for all of that special development, and there's no second sourcing for that technology.
So who would be the user of this kind of product? Is it people editing 8K raw, like 20 people in the office doing that and stuff?
Yeah, so the TrueNAS M series is interesting. You can use it in 2 modes. You can use it for that editing using 8K, and you need sort of 2 gigabyte per second to a client to do that. But in the end, you also have to archive all that video. And for that, you need effectively a larger system with lots of hard drives that isn't necessarily quite as fast, but it stores the data very reliably. And so we can use the M series in both of those modes.
And could you come with a few other examples? It'd be fascinating to understand out of your 2,500, 250,000 customers, like people doing crazy stuff with architecture, with 3D, with... What could it be?
Yeah, there's a lot of different use cases. Diversity is enormous. The community is very entrepreneurial, and it comes up with lots of different ways. For our type of business, the primary applications tend to be virtualization, where people are running their VMware systems using us as a backing store. It's backup itself, where people are backing up their enterprises and making sure that works. The media entertainment industry, so video editing, video archiving, and then we get a lot of also academic and research users that are storing lots of scientific data and using that in different ways and doing analytics on it, etc. So many different use cases for storage systems, and our focus is on trying to be very versatile and make sure that we can support those different requirements without having to change your storage operating system every time you change your application, because that costs a lot of money in terms of training up people to run each storage system if you have unique storage systems for every application.
So a customer could be like a university buying one of these, and then they connect up a bunch of 10 gigabit lines out of this somehow, because you need a lot of these, right?
Yeah, that's right. So 2 different models. One is you build a very big system, and typically you don't put lots of 10 gig connections. What you do is you put it through a switch and and then connect in via 100 gig these days. So that tends to be the model. Or you can have a smaller system in every department, and they operate independently, deliver whatever applications are in each department, and then you can have one central backup system to back up all the data. And so that's also a deployment model that is pretty common.
So there's one scenario that I've been looking for actually for a decade or something like that, and I'm sure you probably have it. But so you know, like the way I back up all my so many terabytes of video is that I'm trying to use cloud, right? But they're a little bit too expensive. So you buy these $149. They used to be $149 like 2 years ago. I hope they got down in price. But those 8 terabyte drives, and so I have to put one at my friend's place, and then have one at my home, and a few, like backup like that. But is there any chance that they could be like totally cold, totally, like not using any power, and on-demand storage that could be very affordable, that you would connect up to maybe some kind of a system like this, where you could just add, like so much extra storage. But with these, I don't know if they're SMR drives or, like the cheapest kind of like external drives you could get, maybe.
Yep, there's a few different ways. The method that I like is that you can effectively, if you have a friend and you both have the a TrueNAS system in your houses, you can back up each other's data. So you can create a VPN between the two of the two units to keep it all secure, and then you can effectively, you back up your data to his system, he backs up your data to your system, and that's a very robust way of doing it. And it it's not zero power, but effectively the incremental power is tiny, so that's good. You can back up your data to a set of drives and take those drives out of the system, and that becomes cold storage. You put that in a firebox, and that's something that many people do when they have to look after their own data. And then we also have a cloud gateway, so you can actually back up data from our NAS to any of your favorite clouds. And so Backblaze, Amazon, etc., can store the data. Though that storage is not cheap. You're still, when you're paying backup data in the cloud, you're still paying reasonably good dollars per terabyte for that backup.
Yeah, I'm like I've been using for a year or a couple of years the $1 per terabyte Amazon, what do you call it, the AWS Deep Archive, Glacier Deep Archive,
Glacier.
something like that. But and I think they have like a minimum of 3 or 6 months that then you can delete it, but you have to keep it for a little while. But it sounds like these kind of systems have huge fees when you actually want to get your data back, and it's always hidden somewhere, and I don't really know where to find the information sometimes, because I'm like trying to calculate what would happen if I lose my data, and then I would have to get it out. But it's even at $1 per terabyte per month sounds like a little, but it's still like nearly 10 times too much. So the real alternative is to kind of like build it yourself, right? And that's what.
Yeah, that's certainly if you want to ever read the data. If you just want to write the data once and never retrieve it, then yeah, Glacier is very good. But if you want to read it at all frequently, then yeah, it's very, very expensive when you read it. So yeah, for someone who wants to make sure that their data is safe and they want to be able to access it whenever they want to, then we recommend having two systems and having a replication to the other system and keeping the cost down by using high capacity drives that are very reasonably priced. But
maybe as a part of your TrueNAS Core might be some kind of system to support. What I want to see is like a very low cost USB hub that connects a bunch of these USB 3. It's only USB speed, right? USB 3 speed, but they would all be powered off 99.99% of the time. But it's just some kind of way to wake them up when I need them, and then.
Yeah, sure. Certainly, you could connect them. Disconnecting them, it's probably possible. But right now, that's not our. We don't do that in our hardware. But that's something that you could do with the TrueNAS Core software.
And here's a question from Norman. I'm curious to know if the solution support Microsoft CSV format, clustered shared volume format.
No, we don't. We support SMB shares, and so I guess to some extent, this is we're saying yes, but we do it in a different way. We don't use the Microsoft file systems underneath. We support SMB shares, and with TrueNAS Scale, we can effectively support a clustered SMB capability, and that gives you both very good reliability, but also very good bandwidth and performance.
And so, what's do you have even more slide, or that's the final one?
No, just a couple of slides to show how things are built. So here's an example of a TrueNAS M-series system. It has two controllers, dual power. The chassis has a built-in backplane, and then you can connect expansion shelves, and you can have drives, and you can have NVMe drives to provide acceleration of the data. So that's how we build these systems. Just to sort of give you an idea of how performance has been improving over the last couple of years, we're starting off with our high-end system a couple of years ago was an M50 running 11.2, and it was delivering 7 gigabytes per second. We improved that with new software, so we're always working on new software to improve performance, got it up to almost 10 gig per second. Did it again with 12.0, got it up to 11.7 gigabyte per second, and then we introduced the M60, which is a slightly higher end hardware and more cores and more memory, and we got it up to 23 gigabytes per second. So our goal is to keep on improving performance and do it through a combination of software and hardware as required.
Nice. There's one thing that I wonder is these Western Digital, Seagate, and the SSD company industry, the NVMe stuff. Are they? You said that there's so much more demand, but wouldn't it be awesome if they could meet the demand with like crazy new technology that it keeps increasing the storage on these kind of magical devices and stuff?
Yep.
How has it been going for the last 18 months? Have they been coming out with these, what do they call them, 100 terabyte dreams and stuff like that on hard drives, or they're still far away?
No, not 100 terabytes. We're generally shipping with 18 terabytes today. We're just starting to test the 20 terabyte versions. They have roadmaps for delivering 24 to 30 terabytes on drives in the next few years. So that's the sort of level. In the end, as you pointed out, though, the other interesting metric is cost per terabyte. So whilst they're increasing those numbers, they're also generally have been generally reducing cost per terabyte, which is great for all the users. Though it's been difficult during the pandemic. The pandemic has caused a lot of supply chain issues, and so people haven't been seeing the same price drops in the last year because of the supply chain issues in the pandemic.
Yeah, there's this question coming in. So are there any concerns with the hardware delivery as it relates to present chip shortages? So the chips that are in those hard drives and SSDs are also in a shortage kind of chaos?
Yeah, what you tend to find is that it's not all chips, it's just some chips that are having problems. And but effectively a complex system like we've got, there are some chips that are in shortage, and so we have to manage that process. So whereas historically we could effectively run our business with 3 months of inventory to manage issues, we now have to go to 6 to plus months, and we have to identify specific things and buy inventory of that in order to make sure we can meet our supplies. So it's actually very complicated at this stage in the way the industry is operating to keep on running properly. But so far we're in good shape and have managed those problems.
And 2-3 years ago, or 3-4 years ago now, with Western Digital and SanDisk, they were talking about doing those 3D NAND technologies to just dramatically increase the storage potential of the SSD stuff. Mm-hmm. Do you see it happening? Do you see SSD ever catching up with hard drives in terms of how much storage you get? And they definitely are way faster in terms of performance, right? And that keeps improving, I guess. But how about the storage per dollar? What's happening there?
So SSDs are way faster from a performance point of view, and so we use them for anywhere that needs performance. You can actually get SSDs that are now larger than hard drives. So you can get 30 terabyte SSDs, which are larger than a hard drive. So there's no problem with capacity as well. They can deliver that. When it comes to cost per gigabyte or cost per terabyte, no, flash is more expensive than hard drives. And so if you want to store a lot of data and just archive it and back it up, etc., then hard drives are still the lowest cost per terabyte if you want access to data. And then people obviously use tape when they just want to write the data and never touch it, but just have it there as a backup in some situations. So the answer is, I think that for the next 10 plus years, you're still going to have hard drives as your lowest cost storage medium, because then the only thing you're buying with hard drives is this magnetic platter. There's nothing intelligent from the point of view of the platter. It's a very low cost medium, and so that's what makes it cheap. And similarly, that's why tape is cheap. It's even cheaper. You don't even have the heads effectively. You just have the magnetic medium of the tape, nothing else. And so that's why it's cheaper.
Because I love my tons of hard drives and they're amazing, but it'd be amazing if the SSD finds some kind of little trick or magical thing to flip the whole business and then suddenly provide for the demand at some kind of low cost. But you're sure that it's not just going to happen in the next decade?
I don't think it will happen that quickly. I think the other problem you've got is even if the flash vendors knew they could do it, if they reduced their price that much, their business would be in trouble. So they really can't do it.
All right, you're right. But this is awesome. Do you would like to talk about the next slide?
Yep. Next slide. Yep. So just a new capability that we really haven't talked about with our community and customers a lot before is that in 2021 we introduced a new M series model. So we did the M60, which I just talked about. But what we've done is we've taken that M60 chassis and used it for all of our M series systems. And by doing that, we effectively get an upgradable path and very good scalability. So all of the reliability, available serviceability stuff is the same, but what we now have is scalability, and we can now upgrade M40s to M50s to M60s, and then scale out to lots of M60s as needed. And the next slide, I'll show you how that works. So you can start with an M40 with a very small configuration. If you want to start with 20 terabytes, either flash or hard drives, you can. You can then scale up by adding shelves, and these are up to 100 bay shelves. And we can then go from there, upgrade to an M50 by swapping the controllers in that M40 system. And when we swap the controllers, we can add more shelves and keep this, do that non-disruptively. So the system is not down during this process. It's we basically just keep on growing it. And then you can upgrade to a full M60 with 12 shelves, and that gives us up to 20 petabyte of capacity in a single system. And we put all that in a rack. So in this case, it would be a very big rack. It would be a 1.2 meter depth, 52U rack, but it all goes in a rack up to 20 petabyte and gives you, very high bandwidth. You can either have one M60 or you can have multiple small M series in each rack. And then with TrueNAS Scale, we can effectively grow the number of racks that you have to keep on growing your capacity. And at this stage, all the technology we use is capable of up to 100 systems in one cluster, and that would be 2 exabyte of capacity. So, do
you have any customers doing that?
We have customers that are doing the M40, M50, M60 today. So that's a standard part of our product line. The TrueNAS Scale, as I said, is in the second beta phase of its release, and so it'll be released in Q4. And so we have customers that are talking to us about doing this next year. And
so they're eager to get their two exabytes.
2 exabytes is big. We're seeing requests for 500 petabytes, so certainly getting up there, but not specifically 2 exabytes right now. 2 exabytes is the technology limit, and then we have real customer issues, and they're in the hundreds of petabytes range at this stage.
Yeah, but the customers are hungry for data, right? So you need you're providing. This is impressive. I can't really understand what is 2 exabytes. It sounds like a lot.
Yeah, it is. So I know that a few years ago, a friend of mine was running the iPhone storage, and so that an exabyte was all the cat photos and videos that the world had on iPhones at that point.
Nice. So you can have 2 times all the world cat and dog photos.
From a few years ago. That was a few years ago. So they probably have 10 exabytes of cat photos and videos now. But,
nice.
That gives you an idea.
I can't understand the scale of YouTube. Like, YouTube is so insane. How much storage do you think they have? They have, like, oh my God, it's insane.
It's very big, but the smart thing that YouTube has to do is to work out how to distribute that video to you. So what they do is they cache the key videos closer to where you are, so you can watch them more easily. And so they have a reasonable size cache system, and then they have a huge repository of video at the back end. But I think you'll find that the iPhone type storage is even bigger, because there's so many private videos that people store. That they have a very big requirement there.
So you're talking about what's on all the iPhones themselves, not the iCloud.
Yeah. No, it's what's backed up to the iCloud, and so people back up their videos to the iCloud and store them there. Yep.
But they put a small limit, no, for the free iCloud.
They do, but there's so many people that are using it that it keeps on growing. Yeah. So it's a pretty big number. But yeah, we find the types of people that need this stuff are people who are building very big archives of valuable data, whether it's scientific data or other information, and so they're the people that need huge systems. All
right. Do you have even more you want to on the slides?
No, that's what I wanted to talk about today. I really appreciate the time that you've given us, Nicholas. So hope it was an interesting conversation for everybody.
Yeah, thanks. It's so awesome. And thanks for all the storage and enabling the systems that store all the storage for everybody. And it kind of like the peer-to-peer aspect of it, where people are being able to manage their own data, because it's one of the most important things you have, right? It's your data, and you don't want to lose it. You don't want to lose those photos and those videos. Right. You might want to learn more about how to do it yourself, or
exactly right. So the demand is still growing, and as you point out, people's data is their lives these days. So we're very happy to be able to provide TrueNAS Core and make it free and help people along. And we get the benefits because we get all the QA. So we get all of the people testing and working with our software. They find all the issues, and that's really valuable for us.
Can you just give a little background of where your teams are based? Are they distributed?
Sure. We're actually distributed pretty globally. We have people everywhere around the globe working on things, but our primary places of work are San Jose and Tennessee. We're in Knoxville, Tennessee. So that's where we have our labs and we have the equipment. But we do have software developers and other people that are located all around the world.
All right, awesome. And you're like a big player in the open source, huh?
Mm-hmm. Yep, that's certainly what we want to do, is be that a leader in that storage side, and it's been working very well for us. Even though it's free, people think, how do you make money out of it? Yes, we can make money by providing good support and service for the enterprise customers.
Cool. All right, okay. And I guess there's roadmaps that are public, or some are secret about what's happening in the future.
We're generally fairly public about it. So we have our community has access to what we call our bug database, which runs on Jira. But that also has all of the tickets we're working on in terms of what the future capabilities of the system are. So we're very open about what we're doing and publish our roadmaps. So the Scale is obviously the big project for this year. We've got some more work we're doing on Scale for next year. So right now we do clustered SMB and scale out S3. We'll be doing clustered NFS and Kubernetes clusters as well, so you can integrate compute and storage on the same systems. And next year we'll also be working on the scaling up the TrueNAS Core and Enterprise side with effectively using FreeBSD 13 as the underlying operating system and improving that with various things, including more use of WireGuard and VPN technologies to provide more security services.
And there's one right here. Are there any preferred data center affiliations we should consider when choosing iXsystems?
A good question. In general, we've tried to be very agnostic to those data center deployments. So the answer is, choose it based on your requirements, whether you need to be close to Amazon for cloud things or whether you need to be close to your own office. Choose your own location, and we'll work with you.
Cool. All right. Thanks a lot. Thanks for your time.
Okay. Thanks,
we can't be doing a full movie. Okay. Thanks for watching, everybody.
Okay. Bye, Nicholas.
Thanks.